So we have seen the graphical representation of the global and the local sequence alignment. Now we will see the score of the path of the local sequence alignment. We have already seen that we have assumed that the subdomain or conserved domain within the gene was almost 1/3 of the size of the gene. So we have assumed that the 2/3n is assigned to the horizontal path and 2/3 also to the vertical path, and the 1/3 is assigned to the diagonally. So we will see how we will calculate and prove it with the mathematical equation. So here we can see that the score of this path is, as we have already assigned it, 2/3n sigma to the vertically and 2/3n sigma to the horizontal edge and 1/3n to the diagonal edge. So if we calculate it, it comes out to be n 1/3 minus 4/3 sigma. So we will prove it how it comes to be. So we know that these two values, minus 2/3 n sigma and minus 2/3 n sigma, they are common in this equation. So we will write these two and rearrange the equation as 1/3 n minus 2/3 n sigma minus 2/3 n sigma. So here we can see that these two are common values. So next step will be 1/3 n. Because these two values are same, we will write as 2, and in the bracket we will write this value 2/3 n sigma. So this is again the same representation of this one, 2/3 n sigma. So in the next step, we will multiply 2/2. Actually this 2 is 2/1. So we will multiply 2 with 2 and 1 with 3. So it comes out to be 2 into 2 is equal to 4 and 1 into 3 is equal to 3. And because this is the common value n sigma, it will remain as such. So in the last step, we can see here that n is common in both of these equations. So if we bring the common n here in the first, then the equation will be 1/3 minus 4/3 sigma. So we can see here that this equation is similar to this equation. So we can calculate this equation by deriving this equation also. So in this way we will come up with this n 1/3 minus 4/3 sigma. So again we can see here we have this derivation of the equation, and we can see that this path also contains so many indels that is unlikely to be the high scoring alignments. So biologically irrelevant diagonal paths likely have score mismatches and are penalized less than indels. Score of diagonal path is n 1/4, 3/4 mu, and since every diagonal edge is 1/4 and the mismatch with the probability of 3/4. Since 1/3 minus 3/4 sigma is less than 1/4 minus 3/4 sigma. So for indels and mismatches penalties, global alignment miscorrect the solution of real biological problem and the biological irrelevant near the diagonal path. In the previous slide, we have seen the graphic representation of the global and the local sequence alignments. And we have also assumed that the gene that has the subsequence of conserved domain, and that conserved domain has the length of approximately 1/3 of the sequence of the gene, and we have assigned the 2/3n horizontal edge and 2/3n to the vertical edge and 1/3n to the diagonal edge. So now we will see the score of the path of the global sequence alignment, and we will try to prove it by the mathematical equation.